HVAC 360, episode number 19. My interview with David Underwood. Welcome back, everybody, to another episode of HVAC 360. I'm your host, Matt Nelson. This week, I have the pleasure of sitting down and talking with a friend of mine, David Underwood. He's Canadian, so don't hold that against him. I appreciate him, and this is actually my first international Skype call. So thank you, David, for being another first for me. This week, we get to talk and learn a little bit about David's background. David's a professional engineer. He's been an owner of his own company, and he's really involved in ASHRAE currently. So one nice thing that you'll, a little bonus bit of information, you'll learn all about square tires. So if you ever wondered what that is and what I'm talking about, let's go to the tape. All right, this week we're talking with David Underwood, who is a professional engineer. He is a resident of Canada A. And how you doing this morning, David?
Very well indeed, thank you.
So I guess one of the things that I want to learn is everybody has their different kind of process, shall we say, in Canada, process to becoming an engineer. What made you want to become a professional engineer?
Well, it wasn't originally the idea that I wanted to be a professional engineer, but it goes a long way back in my history. When I was a child, and I was raised in the middle of Saskatchewan, which is north of North Dakota, and they were building a main highway across the country at the time. And the little town I lived in, they were building a bridge across a creek. And one summer, when I was in grade 7, I sat there fascinated for the whole summer watching them build this bridge. And there was a professional engineer who was actually in charge of the project, and I spoke a lot to that person, and that identified a career that I thought I'd like to pursue. And the interesting thing for me is I did pursue that career, and I became a civil engineer, which is, sort of related to building bridges, and thought that would be sort of the direction of my career. But, it shifted as I left university, and I ended up working for Train. And after I worked for them, I became a mechanical engineer, and the rest is history. I've remained in that discipline ever since. So
was there ever any doubt that you wanted to become an engineer at that point at grade 7? Was that pretty much locked in, or did you kind of say, you know what, if I wasn't going to do this, I'd do something else?
I really don't think I ever had any great ambitions to do anything else other than I've always had an interest in medieval history.
Okay, fair enough. Now, I guess, where did you get most of your education for engineering?
My engineering education was at the University of Manitoba.
Okay. Now, what do you have any favorite subjects or classes that you took?
Well, the interesting thing is my favorite classes were directly engineering classes. I thoroughly enjoyed economics, and the other one that I actually really, really enjoyed was astronomy. Okay.
That was an elective course, an interesting elective course. I've never had
Well, in the University of Manitoba, when I was there way back then, there were no electives. You took everything.
Oh, really? Astronomy was part of the engineering corps?
Yes, it was, as was economics.
Well, I can understand astronomy. I think has a now. How did they?
Well,
really...
because of being in a civil engineering program, astronomy is pretty important in terms of identifying locations and that sort of thing. So you need to have some idea how to actually do navigation.
Okay. So it was tied to navigation, and that interesting.
Essentially, that's correct.
All right.
But it was a very heavy math course.
Now, any interesting engineering schools tend to be, they tend to have these weird stories that occasionally, whether it be like Caltech, MIT, those sort of things. Was there any sort of interesting stories that you had from your college days that you'd care to share?
That probably more of the social nature than of the engineering nature. There were certainly some of them. But the engineering school at the University of Manitoba, its primary focus, interestingly, because it is in the prairies, was agriculture. And they have a very, very good agriculture school there, and there was a form of agricultural engineering that was tied into their agricultural programs. And that was probably the most identifiable thing out of the University of Manitoba at that time. Waterloo in Ontario was recognized as probably the best engineering school in the country, because they had actually started a program of having students go out and work in the marketplace, which was something unheard of at that time.
Mm-hmm. Is that something that you took advantage of, or?
No, we never had that program going at the University of Manitoba.
Oh, okay.
No, I did. My summer jobs were all engineering related, so I did have some exposure, but it wasn't like doing a work term.
Yeah. Now, I guess engineering jobs as a young engineer, what kind of things did you kind of, knowledge and insight, or any aha moments that you gained while working as a young engineer? Anything?
Well, I had a couple of things that sort of directed me to where I ended up going. My summer jobs were always with government institutions. I worked for the federal government of Canada for 3 summers, and I worked for Manitoba Hydro, which is a government-owned entity in Manitoba in my final year. And the concern I had was that looking at what your career development within any of those organizations, there was a very long period of time, and there was a lot of politics, and there were a lot of things that would direct you to a future career that were really related not necessarily to your talent, but to your ability to be there for a long period of time. And I was, as a young man, I was certainly I was somewhat aggressive and interested in having my career go forward based upon my abilities. And I had a friend that went to work for Train, who was a couple years older than me, and he was doing very well, making lots of money, and getting rewarded for his efforts. And that really appealed to me, and that's why I got into this business in the first place.
Excellent. So now, having gone through this process of learning engineering, getting through and establishing a career, what kind of recommendations might you have for people who are trying to get into the engineering field, as far as learning and or trying to break into some ground level, entry level positions?
Well, the first thing is probably to make sure you do as well as you can in school. I mean, if you come out with a reasonably good grade point average, you've got a degree that has credibility, and that is a very important thing in terms of getting an initial interview. Beyond that, you have to have confidence in yourself and your abilities to do something. But you should not express overconfidence, because if you do, that often turns off a prospective employer. Just be yourself and present yourself and the skills that you have available, and your interest and willingness to learn, because an engineering degree is like an apprenticeship program. It is once you've been through it, you have the credentials to learn for the rest of your life.
Now, are there any sort of I know that there's schools in the United States that have engineering based programs, or kind of like sometimes they're referred to as architectural engineering programs, or they're more HVAC oriented. Are there any that you know of in Canada that is that something that is more commonplace than the United States?
Well, our system is slightly different than the U.S. We have universities and we have colleges. Our colleges are not degree granting institutions in the same effect as a university is, but they run a lot of programs. Particularly HVAC and R. That's where it's taught. If you have a university degree in mechanical engineering in this country, you essentially might have had some exposure to HVAC and R, but it's rare. And so if you really want to get exposure, you should be actually looking at a college education, which will not give you an engineering degree.
Mm-hmm. Now,
so that's our differential.
Okay. Now, as far as so you worked for Train for a number of years, and then is that when you started your own company?
Well, I left Train after almost 10 years, and I worked for a mid-size design-build contractor. With the, when I went to work with them, the idea was I was going to be able to get some equity participation, which really, again, appealed to me. And like most things of that nature, it was not going to come to pass. So I spent my last 6 months figuring out how I was going to start my own business before I left them. And then I started my own business in 1975.
So how did that go? How did that turn about?
Well, I try to. I'm somewhat of an honest person, I think. I guess I shade the edges like everybody does if it's absolutely essential. But when I left that company, it was my decision not to walk away and take any of their clients. So I actually started my business with absolutely no customers. And I spent a lot of time on the phone talking to my contacts and people that I knew outside of my contacts from the employment I had with the former contractor. So it took me quite a while to establish it. It took almost 3 years before we actually turned our first profit.
Wow. Excellent. Now, I guess some of the things that you obviously had a lot of experience with design build. I guess what do you think is the trend nowadays with design build? Is it growing? Is it shrinking?
Well, from my observation, it certainly is growing. My design build experience is not of the nature of what's happening these days with P3 projects and that sort of thing. I was always small, and I intended to keep it that way because I liked hands-on. I liked to do what I did. I liked to be involved in the design. I liked to be involved in the construction, and I liked to be involved in the commissioning, where I turned the product over to the owner and taught their personnel how to operate it, to its best effect, on behalf of the owner for what he was looking for in his project requirements to begin with. I think some of that gets lost when you get into larger projects. And you have a lot of, again, you're going back to having all the disciplines involved. You'll have an architect, you'll have a mechanical engineer, you'll have an electrical engineer, you'll have a structural engineer. And oftentimes integrated design gets lost in that mix. And so I think the bigger design build projects tend to have some problems that are similar to the traditional design build method. So I'm not 100% confident that the large design build projects have a great deal more success than the old traditional way of doing a construction project.
Okay. Now you mentioned P3. What is that? P3.
Well, that's really sort of the government's way of putting a project off the balance sheet. Like somebody will design. And I forgot what all the P stand for, but it's private, and there's private funding comes in, and then the private funder, well, they don't own the project, they operate the project for a certain period of time, and at the end of which they turn it back over to the government. So the government gets an asset that they never actually had on their books.
Okay, so it's more of a
and that's more like hospitals and schools and that sort of thing.
So performance.
And universities are involved in that too, quite a bit.
More performance contracting, you'd say.
Yeah, exactly.
Now, as far as the design build projects that you were dealing with, you were mostly dealing with was it smaller? Was it like additions or remodels or things like that were in existing facilities?
There was some of that. There was a lot of stuff where we were involved on the industrial side where, somebody would have a particular project they were working on that required some unusual control system or some unusual refrigeration systems or whatever, and we try and design a solution to the problem they were trying to solve.
Okay.
So we were working within the confines of something that was already existing in most cases.
Now, the benefits of design build, do you think it's the benefits that you saw doing, the more kind of internal projects Do you think that the same benefits of having the engineer look over the construction, look over the commissioning of it, or actually do the commissioning of it? Do you think that benefit kind of does it extend to the larger design build projects or?
To some extent, and a lot of design build is a lot like commissioning, in my opinion, and that's the integrity of the people that are actually doing that particular kind of work. And if you're only in it to make money, I think it'll fail. If you're in it because you believe in giving appropriate solutions, not just one-off, it's looking at good, better, best ways of doing things for your client. And spending the time at the upfront design part of the work so that you can give the options to the owner, and the owner can select from a range of things that may do the project for him in a good, better, or best manner. So I think some of that gets lost as you get bigger and bigger.
Okay. So I guess what are some obviously since you have a lot of experience, what's some of the tips to doing design build right?
The tips, in my opinion, is that you need to have lots of contact with owners, and there are many ways of doing that. It's being involved in your community, being involved with clubs and organizations, where your credentials you can talk about them, and people who have problems, if you sit down and have discussions, you can then maybe say, well, look, maybe I can help you in this area. And it's that networking, and the networking actually within ASHRAE helps that sort of thing a lot as well, because you learn, you meet people, and I have often actually done some design build work for consulting engineers.
So what, I guess, what you have any other lessons learned what are some of the examples of things that have gone wrong that you've learned from the past not to do again?
Well, I guess the lessons gone wrong is being overly enthusiastic about how well you can do a project and underbidding what is probably necessary in order to make the job profitable. But I never backed away from a job. If I was losing money, I completed it anyway, whether I lost money or not. And I had several of those over my career.
That's a valuable lesson. Now, I guess what is your as long as I've known you, what is your fascination with refrigerant? How is that relationship between you and refrigerant?
Well, maybe I smelled too much of it as a kid. I'm not sure. What I liked about it is that my company, until I started bringing in partners, which was sort of 17 or 18 years after I started the business, the people who worked for my company, were all refrigeration mechanics, and they were in Ontario. They go through a 9,000-hour apprenticeship. They're all very talented people, and I like to work with them. And I was out in the field with them, and I enjoyed a lot changing compressor, changing component parts, doing some piping, and all the things involved where there's a fair amount of technology involved in piping systems and refrigeration systems, which don't apply when you get into other fluids. As fluids and machines, there's a lot more complication than there is between pumps and chillers, in my opinion.
Now, what are some of the common things that go wrong with refrigeration systems?
The common things that go wrong with refrigeration systems is oversizing pipes so you don't get appropriate oil flow back to your compressor, and if that happens, you've got big trouble.
Okay.
And the other thing that is a big problem is a lot of people want to use hot gas bypass, and in my opinion, that's a mug's game from 2 points of view. Number one, it's an energy hog, and number two, you can often overheat your compressors, and again, that leads to a lot of failure.
So you're not a big believer in hot gas bypass?
Absolutely not.
All right. I have to ask from a refrigerant standpoint, you being in Canada, is the low ambient options that we would find down here in the States, Are they like more of like a requirement? Like nobody asks, whether or not they want low ambient, they automatically get it? Is that?
Well, in where I live in Toronto, not so much. But if you live in Winnipeg, it's automatic.
I know this from experience in my. I used to own a car, a Dodge Omni, and there was actually it had no air conditioning, but it had a block heater because it was from Minnesota. But if you bought the same car down in Texas, you'd get air conditioning automatically, but there wouldn't be a block heater. So,
in Winnipeg, what you got when I went to university, everybody used to line up at the when you registered, there was a long lineup so that you could get a parking spot with a post that had a plug-in, so you could start your car in the middle of the winter.
That is amazing because I know that just growing up in northern Minnesota, it was leaving your car running and taking your keys with you. You can't do that nowadays, but people would do that. Just let their cars run because they went into the grocery store or something. They just let the engine run and so it wouldn't cool down.
Yeah, Matt, one of the things you may not have experienced, but you probably did in northern Minnesota. Have you ever had square tires?
I have not had square tires, thankfully.
I've had them many times, and that's and just for the people who have no idea what I'm talking about. That's in the winter when it gets so cold that your tires actually freeze, and when you start to drive, you've got the bottom of your tire is flat, and it goes thump 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 until there's enough heat built up in the tire for them to get round again.
It's amazing.
It's quite an experience because it's quite noisy, quite loud, and quite uncomfortable.
Oh, so you now pretty much you're retired now from business life, and you've kind of thrown yourself into ASHRAE. What are some of some of the things that you're involved with ASHRAE?
Well, right now I'm fortunate enough to be a vice president, and that is a nominated position, and it expresses a lot of confidence from the membership, and for that I'm very, very grateful, and I'm very honored. And it's a huge honor. It's not just that you've been there for a long time. You are very much honored to be able to have these positions, and with that comes a great deal of responsibility on behalf of the membership, of which I'm very much aware. In my other sort of situation as a VP, I'm also in chair. I'm also right now the chair of the Publishing and Education Council, which is the part of ASHRAE that develops and produces the handbook and the journal and all our professional development courses and those things, which I think are of a great deal of benefit for all of our society members.
Oh, absolutely. Now, let me ask you a question, I'll put you on the spot since I know you're on publications then. But the handbooks, I know that there has been some opinion. If you're an engineer, if you looked at the ASHRAE handbooks, they're not. I mean, they're a great resource of information. They're very definitive. They're put together by industry experts, but they're not easily digestible by somebody who may not know as much as the person who wrote it. How is that being handled in society? I mean, is there a push towards making the handbooks a little bit more user friendly, or is that going to be supplemented by other other courses to kind of say, okay, well, if you really want the technical explanation of heat loss, you go to this chapter, but if you want to kind of learn a more hands-on approach, you take a course, or how is that being handled in ASHRAE society?
Well, I would say there's probably a mixed bag of that, because all chapters. I mean, there's kind of it's like the publishing industry. We have a committee that's part of the Publishing Education Council that's responsible for the publishing of the handbook, and then you have all the TCs who are the authors, and they're responsible for the actual content. And in those interactions between the handbook committee and the TCs, they're kind of looking at editorializing it so it's readable and it's understandable as best it can be from some of the complex technology. Mm-hmm. I would say that there's probably somewhat of a mixed bag on putting things into a more easily read form. But one of the things that's often been pushed is things like rules of thumb. And I have a friend of mine who sat on Handbook for 12 years, and he's got a very interesting concept about rules of thumb. That's ROT, you know what that spells. So that's the difficulty in trying to get down to simplifying things, you know, for the designer or the engineer who has not got much technical knowledge in this particular area. Is if you get down to doing rules of thumb, you know, are you really giving something that's credible for a society that's involved in technology? That's who we are. If you want more information, one of the things and where you really have to go in the handbooks is you have to go to the bibliography, and in there, you know, there's a lot, and the reference materials that are used, and that's where you can really, if you really want to delve into a subject, that's where you have to go, and the handbooks are there to tell you how to get to those areas.
You know what? That's I've never thought about that portion of it, but you're right. There are those bibliographies in back there, and
they are a very important aspect of the handbook. A lot of people don't even think about.
Yeah, I'm one of those. So now I've been enlightened. Thank you.
You're quite welcome.
So now you are a ASHRAE fellow.
That's correct.
How does one get that designation? That seems pretty. You know, I don't know.
Well. Again, that's an honorific. I mean, there's a couple of limitations. I think, first of all, you have to be a member for a minimum of 10 years, which I qualify for that quite easily. And it's really looking at your career in engineering. It's not specifically tied to HVAC&R. It's tied to what you've done. And in my case, you know, I've been, I'm a bit of a gadfly, and I've been involved in a lot of things. And from writing, writing a safety manual for the refrigeration trade in Ontario to lobbying with the Ontario government over refrigerant management, and ozone depletion and those sorts of things, to my work at ASHRAE, to some of the design build work I've done. So it really is a compendium of all those things. And it is reviewed by the Honors and Awards Committee, and in actual fact, to become a fellow, it eventually goes before the board. The board of directors have to approve every person whose name comes forward, you know, from the Honors and Awards Committee to actually be awarded the fellow in ASHRAE.
Wow. Well, congratulations on that.
Well, thank you again.
So you had written a manual on safety for refrigerant?
Yeah, in combination with other people. It wasn't me alone, but okay. It was, you know, I was involved with it.
Okay, so I have to ask you, what are some of the safety tips if you're going to be dealing with refrigerant, just off the top of your head?
Oh, off the top of my head, I mean, it's making sure that if you're going into a contaminated chiller room, that you've got proper breathing apparatus on. It's making sure that you don't you don't expose yourself to refrigerants on your skin surfaces, because they will very quickly freeze you. It's all the other things about safety, climbing ladders, where you work. And it's a lot to do with construction safety, because it's a construction type trade, and there's all those things about making sure that you have guardrails and et cetera, so people don't fall and hurt themselves. And because that's in Ontario, the single biggest injury in the construction industry is falls.
Be safe.
And we studied a lot of statistics when we were developing this program.
Wow. Now I know that was this during that transition from R22, phasing that out, going to 410A or 407C, the different refrigerants that actually operate at higher pressures? Is that? I mean, I think that there will be a lot of safety concerns relative to that.
Well, let me straighten that part of it out. When I wrote this book, that was before we got into the Montreal Protocol. It was that long ago.
Okay. All right.
Yeah, but that book is still in print. It has been updated, but it's still in print.
Yeah. I mean that I'll agree with you. I mean as far as things go, engineering wise, refrigerant and refrigerant design is something that is not for the faint of heart. Yeah, it's interesting. It's interesting to note that.
That may be a little bit of a strong statement. I find it very interesting. It's challenging, and it's interesting because like if you are an engineer and you truly like engineering, you like challenges. And again, something else that I've always felt about engineering, it's a matter. A lot of people think about it as being a very precise science, which it isn't. It is a look at the best information you can get for trying to apply some engineering principles or scientific principles to solving a problem. And it ends up being risk management because you don't always have the information you need.
Okay. Yeah, and I would totally agree with you. But my statement about refrigerant, just so I can clarify that, I when you talk about R11, R22, it's well documented. That's nice and fun. When I took a look at 410A and 407C and some of these other refrigerants, I don't know if they've gone to the same depth of explaining. Okay, what are the properties? What kind of pipe do you need? What are the charts that you need to review? I think it almost seems like way back when they kind of published that information, but now it's kind of I've seen a lot of cases, especially with variable refrigerant.
I can explain that to some degree. Part of what has happened is that under what is called the SNAP program in the U.S., which is a rapid, so the rapid development of these refrigerants, as a result of Montreal Protocol, they came on the market and before people had time to do the research to do proper design for those new products and those new fluids and their flows, etc. And so what has happened is that they've looked at the tables and data that have been used before and tried to adjust them. So they may not necessarily be exactly accurate at this point. And that, I think, can lead to other problems when you're into piping systems. Although it appears that more and more systems are actually being packaged and piping is not used as extensively as it used to be, from what I can observe.
Right, and especially with the variable refrigerant piping, I think that's probably the biggest area where, but that's all based on computer models that you get from software used by the factory.
Which you have to have because it's dynamic as opposed to the other systems which were, there's a dynamic flow. It was really static in nature.
Okay. All right. Well, David, I appreciate your time. Is there any other parting remarks that you'd like to tell anybody?
Well, I just first of all like to thank you very much, Matt. I've worked with you before, and I've always found it interesting. I think you're a very talented young man, and thank you very much for doing the work you do.
All right. Well, thank you. And I think that pretty much does it. So thank you, David, and good luck in your ASHRAE endeavors.
Thank you very much. Appreciate it.
All right, we're back. I want to thank again David Underwood. There's a lot of thanking going on in this episode. But thanks, David, for taking the time to talk with us about his career throughout engineering. He has a lot of good things that he has, that he can add to the situation. And I think, frankly, I've talked about it before, but networking, comes up again and again. It's important. If you want to be an engineer, you really don't sit in a cubicle and be a good engineer. You get out there, you meet people, you learn about who the contractors are, who the representatives are. You really get to. It's a very kind of social thing that this professional engineering has become, because that's the way you become your best. Also, another interesting tidbit that I learned, thank you, David, is the bibliographies. I'd never kind of thought about that. I've always done that with papers. It seems that if I want to find out exactly, okay, where did this paper get this information, so I could kind of do some deep diving on a subject, I'd always look at the bibliography of an article that I'm reading or a paper. But I've never thought about the ASHRAE handbooks like that, so I will have to take a new look at the bibliographies of the ASHRAE handbooks. So, again, kudos for David for pointing that out. And there again, I think that if you like this episode, let me know. You can reach me at matt@buildingx.co. And if you follow me on Twitter, I'm at BuildingX. And also, I'm on LinkedIn. So if you want to get a hold of me, give me any suggestions, feedbacks, it always would be greatly appreciated. I appreciate each and every one of my listeners, and thank you for listening. And remember, know what you build, and share what you know.